Okay, we have our Stroop data now where we have filtered out the inaccurate trials and we have calculated the mean and standard deviation and excluded trials where participants were too slow, where their reaction times were more than 2 standard deviations above the average. And now what I want to do is show you how you can use pivot tables to summarize your data in a really quick and easy way. So what you want to do to put in a pivot table is select the data that you are interested in. So you can put our cursor in the top left corner and use Control, Shift, and then a cross arrow and down arrow to select all of our data from all 20 participants. Then you go Insert Pivot Table. So it's telling you that it's selected this range of data and it wants you to tell it where you want it to put the pivot table. So you can put it in a new worksheet, but often you want to look at it with your data. So put it in the existing worksheet this time and just click a location on the spreadsheet and go OK. Now what pivot tables allow you to do is to set up a table that summarizes the data in whatever way is interesting to you. So in this case, maybe we would like to look at individual subjects' reaction times averaged across the trials as a function of condition. So in this case, we might want to put the subject number as the rows in our table and the condition as the columns in our table, and then the reaction time as the values of the data. Now, what it's done here is it's actually added, so it says sum of reaction time, it's added the reaction times together for all condition 1 trials, for each subject, for all condition 2 trials. Now, you want to make sure that you check that the default setting here is what you want. In this case, we're not necessarily interested in the sum of reaction times, we're more interested in average or mean reaction times. So you can click on this arrow and change the value field settings to choose count or average or max or min or whatever you're interested in. In this case, I think average makes the most sense. So we have now we have a table that summarizes for each of our participants 1 through 20 what their mean reaction time was for trials of condition 1, condition 2, and condition 3. And then down the bottom it gives us averaged across all our participants what the mean reaction time for condition 1, 2, and 3 is. Now we can check that it's doing what we want it to do by inserting another pivot table that essentially averages across participants. So if we select our data again, and go Insert Pivot Table, and this time we'll just put the pivot table next to the other one. And this time what I want to do is just have it give me reaction times as a function of condition, averaging across participants. Now again, the default here is sum when we are really more interested in the average. So you change that and you can see that what the pivot table has done is this time averaged across participants, and it gives you the same values here. So you can see them in 0.65, 0.75, and 0.77, the same values here when you average across participants as it gives you here at the bottom. All right, now that we've got the mean reaction time averaged across our participants for condition 1 and 2 and 3 in our Stroop task, what I want to do is show you how to graph that and add error bars to your graph so that we can get a kind of ballpark idea about whether it looks like these reaction time differences would be statistically significant. So we have on average a few hundred milliseconds difference between each condition, but when we're talking about reaction times, and if the reaction times are consistent, then maybe those will turn out to be statistically significant. All right, so the first thing we want to do is just copy and paste these values from our pivot table into the sheet so that we can change the values in the pivot table and get standard deviations as well. So let's just right click and copy, and we'll paste it down here. In this case, it's a good idea to paste the values because there are all kinds of formulas hanging in the background of pivot tables that can mess with things. So here we have reaction time as a function of condition, and then we can click on a pivot table and simply change the values to get the standard deviation as well. So if we come down here, it's going to give us the standard deviation of reaction time as a function of condition. And if we copy those values, put them here, then we can use our standard deviation values to calculate a standard error. So when you're plotting graphs, it's always a good idea to plot error bars on your graphs. It gives your audience who are listening to your presentation a kind of visual indication of whether differences between conditions or groups are likely to be significant. So we can calculate a standard error from a standard deviation, and as long as you know the n, how many participants there were. So standard error simply is calculated as the standard deviation divided by the square root, SQRT, of n. So in this case we have 20 participants. Okay, so we can just drag that formula down, and now we have standard error. Okay, so let's draw a simple bar graph of this reaction time data.